The first winLIFE example evaluates the nominal stresses in a shaft cross-section with regard to material fatigue. In addition, some basic functions of the software will be demonstrated. After a file name has been specified, the nominal stress method is selected. Only one load is to act on the shaft. The load curve is to be evaluated precisely. We want to represent the cyclically acting nominal stress in the form of a stress collective. The SN curve shown is selected from an existing data set of SN curves. The window contains information that fully defines the SN curve. For this example, we note the fatigue strength of approximately 197.5 megapascals. This is because we want to specify the nominal stress at this level later on. The Hague diagram is shown here for information purposes, as this representation is frequently used. The stress collective is already available as a file. We display it graphically and see a one-stage collective with a maximum stress of 100 megapascals and 10 cycles. In this first calculation variant, we leave the values as set. We perform the calculation and obtain no damage amount. The SN curve shows the nominal stress load of 100 megapascals. This value is well below the fatigue strength. The blue rectangle also shows the 10 cycles of our collective. We will now switch the method to a uniaxial simplification. This means that the nominal stress is no longer evaluated exactly, but is divided into classes. We can see the classification options in the calculation parameters. We are working with 100 classes. The upper and lower class limits are calculated automatically here. These are 101 and minus 101. The total damage is also 0 here. In the next variant, we increase the nominal stress. We do this by scaling the collective by a factor of 5. The new collective can be shown graphically. Now there is damage. The method is switched back to the uniaxial simplification. We leave the automatic classification setting unchanged. We perform the calculation. The following diagram clearly shows that the effective nominal stress in the shaft cross-section exceeds the fatigue strength. This results in damage. After being significantly below the fatigue strength and significantly above the fatigue strength in our test variants, we now want to try to hit the fatigue strength exactly. To do this, we set the multiplier for our stress collective to 1.9751. The result is the damage amount shown. Now we increase the number of cycles in our collective so that a total of 1 million cycles are applied. This would then be at the buckling point of the Waller curve. And we now achieve the expected value of 1.0 as the damage sum because we now achieve exactly the fatigue strength at the corner point. This can be seen graphically. We now also calculate with the uniaxial simplification. We obtain a value close to 1.0 as the damage sum. The rain flow matrix is also shown here, but it only has one column because the stress collective is single stage.